Hey, welcome back. The first part of this video got a little lengthy, so we went ahead and split this lesson into two parts. In the first part of this lesson, I explained how the NOT, and OR gates worked, and in this video, I'll explain how the NAND, NOR, and XOR gates work. The second half of this lesson, which is this video, should be easier to follow since we went over some of the basics, which are the NOT and OR gates. Alrighty, let's go ahead and jump in. The very first gate that I'll be showing you all today will be the NAND gate. And the NAND gate essentially stands for not and. And the not and gate, or the NAND gate, looks very similar to the AND gate, except at the head of the symbol there is a little not sign, or this little circle up front. And if you remember, what the NOT gate does is that it flips that bit. So I'm just going to go ahead and draw out our AND table just to jog back our memory. We have our two inputs, our X and our Y, and then we will have our AND output. We'll also have our NAND output. And this will actually be fairly simple, as I will show you all. So just to jog back our memory, we had 4 different variations of inputs. So for the AND gate, I explained that using a series circuit. So when both switches are open, the light bulb won't turn on. If only one switch is open and one switch is closed, the light bulb still doesn't turn on. Same scenario, if the first switch is closed but the second one's open, the light bulb still won't turn on. Both switches have to be closed and then the light will turn on. Okay, so that is the output for our AND gate. And for our NAND gate, it has that NOT symbol at the very front like I was talking about. So what that does is it flips that bit. So it is actually the exact opposite of the AND gate. So this will be 1, 1, 1, 0. Okay, simple enough? That's pretty much all it is. Alrighty. Now the next gate that I'm going to go over will be the NOR gate. And the NOR gate, much like the NAND gate, stands for not OR. And the NOR gate looks very similar to the OR gate, except that it has this NOT symbol attached to the head, kind of like the NAND gate. And this is also very similar to the OR gate, in the same way that the NAND gate is similar to the AND gate. So I'll go ahead and draw out our table to jog back our memory. So I'll write out our OR output and our NOR output. Okay? And with 2 inputs, you'll have 4 different variations. So in the first video, I used the example of a parallel circuit. So the parallel circuit, once again, will look like this. That's the bulb. Okay, and these will be our switches. So if both switches are open, then the light bulb won't turn on. If one of these switches is closed, if the second one's closed, then the light bulb will turn on. If the top one's closed but the bottom one's open, it'll still turn on because the electricity has a way to flow through there. And if both are closed, the light bulb will also turn on. Okay? And the NOT OR gate is essentially the opposite of the OR gate. So 0 will flip that bit, it'll become a 1, this will become a 0, 0, 0. Alrighty, So that is the NOR gate. Pretty simple, pretty straightforward. Alrighty. Now for our last gate, this will be the most complicated out of the total of 6 that I'll be showing you, that I have showed you, and that is the XOR gate, or also known as the exclusive OR. And I say that this is the most complicated because the XOR gate is actually a combination of 3 gates. It is a combination of the OR gate, NAND gate, I'll explain these a bit more right now, and then the outputs of these will feed into an AND gate. Okay? So I'm going to write little notes in case you don't remember. That is an OR gate. That is a NAND gate. And this is an AND gate. Okay? And I'll go ahead and draw out a table to the right hand side so we can keep track of our outputs. So we'll have 2 inputs, once again, right here. This will be our X, this will be our Y. And we will have 1 output. Out. That looks terrible. Out. Okay. Go. So we'll have the same 4 combinations because we only have 2 inputs. So we'll go ahead and start off with the first 2 combinations where we have a 0, 0. So let's go ahead and start off with the OR gate. 0, 0 fed into an OR gate will give you an output of 0. That means both switches are open in a parallel circuit, so the light bulb will not turn on. And for this, we'll go ahead and analyze it as an AND gate first, and then we'll flip the bit. So 0, 0 through a series circuit. So let me just write these down at the bottom for us to remember. Parallel, we'll have 2. And then series, we'll also have 2 switches, but they're pretty much reliant upon both of them being closed. Okay, so for the AND, if both are open, if both switches are open, then the light bulb will not turn on. But since it's a NAND gate, we'll go ahead and flip that. So it'll be a 1. And then now the outputs of our OR and NAND gates will get fed into our AND gate as inputs. So for the AND gate, we'll have a 0 and a 1. An AND gate will be a series circuit, so the first switch will be open, second switch will be closed. That means that light bulb will not turn on, so we'll get an output of 0. Okay? So when our inputs are 0, 0, we'll get an output of 0. Alrighty, hopefully we're able to follow that. I'll go ahead and flow through the next couple of examples. Now we're going to go ahead and have an input of 0 and then 1. Okay, so output, or an input, sorry, of 0 and 1 into an OR gate. That means one of these gates, one of these switches is closed, which means that that light bulb will turn on. We'll get a 1. And then for our AND gate, If one switch is open and one switch is closed, that light bulb will not turn on, so that'll be a 0. But since it's a NAND gate, we're going to go ahead and flip that, so it'll be 1. These two outputs of these two gates will turn into inputs for this AND gate. So 1 and 1 into an AND gate will mean that both of these switches are closed for the series circuit, which means that light bulb will turn on. So we'll get an output of 1. So when we have inputs of 0, 1, we'll get an output of 1. Okay? Go through the next example. Which will be inputs of 1 and then 0. So for our OR gate, which will be the parallel circuit, one of the gates will be open, one of the gates will be closed. So that means the light bulb will turn on. And then for our AND gate, that's our series circuit. That means the first gate will be closed, the first switch will be closed, the second switch will be open. So the light bulb will not turn on because we need both of them closed. So we'll get an output of 0, but since it's a NAND, we'll go ahead and flip it. So that'll be an output of 1. These two outputs will turn into inputs for our AND gate. So 1 and 1 into an AND gate, which will be the series circuit, means that both of these switches are closed. We'll get an output of 1. Ready? So with an input of 1 and 0, we'll get an output of 1. Okay? And then for our last example, we'll have inputs 1, 1. So for our OR gate, which will be our parallel circuit, both of the switches will be closed, so the light bulb will turn on. That'll be an output of 1. And for the AND gate, which is our series circuit, both gates will be closed, or both switches will be closed, so then our light bulb will turn on. So that'll be an output of 1, but because it's a NAND gate, we're going to flip that bit. We'll get an output of 0. And now 1 and 0 will be inputs for our AND gate. And once again, that's a series circuit. So the first gate will be closed. Sorry, the first switch will be closed. The second switch will be open. And that will not turn on that light bulb. So we'll get an output of 0. Okay, so if we just look at this table to our right-hand side, we'll see that we'll only get an output of 1 if exactly one input is a 1. If we get two inputs, both 0, we'll get an output of 0. If both inputs are 1s, we'll also get an output of 0. So there has to be exactly one. In this scenario, only one input can be 1 at a time for us to get a result of 1. Alrighty, so that goes ahead and wraps up our second part of our Boolean logic lesson. So if you thought this was useful, if you thought it was helpful, go ahead and give us a thumbs up, and we'll go ahead and transition into our third video. Awesome.